referring to an item in the module tree. To show Rust where to find an item in a module tree, we use a path in the same way we use a path when navigating a file system. To call a function, we need to know its path. A path can take two forms. An absolute path is a full path starting from a crate root from code to an external crate. The absolute path begins with a crate name, and for code from the current crate, it starts with the literal crate. A relative path starts from the current module and uses self, super, or an identifier in the current module. Both absolute and relative paths are followed by one or more identifiers separated by double colons, returning to listing 7-1. We say we want to call the add to waitlist function. This is the same as asking what's the path of the add to waitlist function. Listing 7-3 contains listing 7-1 with some of the modules and functions removed. We will show two ways to call the add to waitlist function from a new function, eat at restaurant, defined in the crate root. These paths are correct, but there's another problem remaining that will prevent this example from compiling as is. We will explain why in a bit. The eat at restaurant function is part of our library's create public API, so we mark it with a pub keyword. In the exposing paths with the pub keyword section, we will go into more detail about pub file name src slash lib.rs. Okay, I have this I have mod within a mod, and then I have a public function. The first time we call the add to waitlist function in eat at restaurant, we use an absolute path. The add to waitlist function is defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. We then include each of the successive modules until we make our way to add to waitlist. You can imagine a file system with the same structure. We would specify the path front of house hosting add to waitlist. To run the add to waitlist program, using the crate name to start from the crate root is like using to start from the file system root in your shell. The second time we call add to waitlist in eat at restaurant, we use a relative path. The path starts with front of house, the name of the module defined at the same level of the module tree as eat at restaurant. Here the file system equivalent would be using the path front of house hosting and add to waitlist starting with a module name. Means that the path is relative. Choosing whether to use a relative or absolute path is a decision you will make based on your project and depends on whether you are more likely to move an item definition code separately from or together with the code that uses the item. For example, if we move the front of house module in the eat at restaurant function into a module name customer experience, we would need to upgrade the absolute path to add to waitlist, but the relative path would still be valid. However, if we move the eat at restaurant function separately into a module named dining, the absolute path to the add to waitlist call would stay the same, but the relative path would need to be updated. Our reference in general is to specify absolute path because it's more likely we want to move both definition and item calls independent of each other. Okay, the error message is that the module hosting is private. In other words, we have the correct path for hosting module and the add to waitlist function, but Rust won't let us use them because it doesn't have access to the private section. In Rust, all items, function, method, struct, enums, modules and constants are private to parent module by default. If you want to make an item like a function or struct private, you put it in a module. Items in a parent module can't use the private items inside child modules, but items in child module can use the items in their ancestor modules. This is because child module wrap and hide their implementation details, but the child module can see the context in which they are defined. To continue with our metaphor, think of the privacy rules as being like back office of a restaurant. What goes in there is private to restaurant customer, but office manager can see and do everything in the restaurant. The operators used to have the module system function this way so that hiding inner implementation details is the default. That way you know which part of the inner code you can change without breaking outer code. However, Rust does give you the option to expose inner part of child modules code to outer and sister modules by using the pub keyword to make an item public. Exposing paths with the pub keyword. Let's return to the error in listing 7-4 that told us the hosting module is private. We want the eat at restaurant function in the parent module to have access to the add to waitlist function in the child module, so we mark the hosting module with the pub keyword as shown in listing 7-5. Okay, so unfortunately the question results in an error. What happened? Adding the pub keyword in front of mod hosting makes the module public. With this change, if we can access front of house, we can access hosting, but the contents of hosting are still private. Making the module public doesn't make its content public. The pub keyword on a module only lets code in its ancestor modules refer to it, not access its inner code. Because modules are containers, there is not much we can do by only making the module public. We need to go further and choose to make one or more of the items within the module public as well. The error in listing 7-6 says that the add to waitlist function is private. The privacy rules apply to struct enums functions and methods as well as module. Let's also make the add to waitlist function public by adding the pub keyword before its definition as in listing 7-7. Mod front of house pub mod hosting pub function add to waitlist pub function eat at restaurant create front of house hosting add to waitlist. Okay, now the code will compile to see why adding the pub keyword. Let us use the path in add to waitlist with respect to the privacy rule. Let's look at the absolute and relative path. In the absolute part, we start with create the root of our create module tree. The front of house module is defined in the create root, while front of house isn't public because the eat at restaurant function is defined in the same module as front of house. That is, eat at restaurant and front of house are siblings. We can refer to front of house from eat at restaurant. Next is the hosting module marked with pub. We can access the module parent module of hosting, so we can access hosting. Finally, the add to waitlist function is marked with pub and we can access its parent module, so this function call works. In relative path, the logic is the same as the absolute path except for the first step. Rather than starting from the create root, the path starts from front of house. The front of house module is defined within the same module as eat at restaurant, so the relative path starting from the module in which eat at restaurant is defined works. Then because hosting and add to waitlist are marked with pub, the rest of the path works and this function call is valid. If you plan on sharing your library grid so other projects can use your code, your public API is your contract with users of your grid that determines how they can interact with your code. There are many considerations around managing changes to the public API to make it easier for people to depend on your grid. These considerations are out of the scope of this book. If you are interested in this topic, see the Rust API guidelines. Best practices for packages with a binary and a library. We mentioned a package can contain both src slash main.rs binary crate as well as src lib.rs library crate root, and both crates will have the same package name by default. Typically, packages with this pattern of containing both a library and a binary crate will have just enough code in the binary crate to start an executable that calls code with the library crate. This lets other project benefit from the most functionality that the package provides because the library creates code can be shared. This the module tree should be defined in src slash lib.rs. Then any public items can be used in the binary crate. By starting path with the name of the package, the binary crate becomes a user of the library crate, just like a completely external crate would use this library crate. It can only use the public API. This helps you design a good API. Not only are you the author, but you are also a client. In chapter 12, We will demonstrate this organizational practice and with a command line program that will contain both a binary crate and a library crate. Starting relative paths with super, we can construct relative paths that begin in the parent module rather than the current module or the crate root by using super at the start of the path. This is like starting a file system path with the double dot syntax. Using super allows us to reference an item that we know is in the parent module, which can make rearranging the module tree easier when the module is closely related to the parent, but the parent might be moved elsewhere in the module tree someday. Consider the code in listing 7-8 that models the situation in which a chef fixes an incorrect order and personally brings it out to the customer. The function fix incorrect order defined in the back of the house module calls the function deliver order defined in the parent module by specifying the path to deliver order starting with super. The fix incorrect order function is in the back of the house module, so we can use super to go to the parent module of back to house, which in this case is create the root. From there we look for deliver order and find it. Success. We think the back of the house module and the deliver order functions are likely to stay in the same relationship to each other and get moved together should we decide to reorganize the crates module tree. Therefore we use super, so we will have fewer places to update code in the future if this code gets moved to a different module. Making structs and enums public, we can also use pub to designate structure and enums as public, but there are few details extra to the usage of pub with structs and enums. If we use pub before a struct definition, we make the struct public, but the structs fields will still be private. We can make each field public or not on a case by case basis. In listing 7-9 we have defined a public back of house breakfast struct with a public toast field but a private seasonal fruit field. This models the case in a restaurant where the customer can pick the type of bread that comes with a meal, but the chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customer can't choose the fruit or even see which fruit they will get. Okay, so they have a mod, then they have pub struct of breakfast and implementing the breakfast. Okay, then eat at restaurant, we can directly call back of house breakfast and the summer method. Because the toast field in the back of house breakfast truck is public in eat at restaurant, we can write and read to the toast field using dot notation. Notice that we can't use the seasonal fruit field in eat at restaurant because seasonal fruit is private. Okay, try uncommenting the line modifying the seasonal fruit field value to see what error you get. Also note that because back of house breakfast has a private field, the struct needs to provide a public associated function that constructs an instance of breakfast. We have named it summer here. If breakfast didn't have such a function, if we couldn't create an instance of breakfast in eat at restaurant because we couldn't set the value of the private seasonal fruit field in eat at restaurant. In contrast, if we make an enum public, all its variants are then public. We only then need pub before the enum keyword as shown in listing 7-10. So I have a mod over here, pub enum. Because we made the appetizer enum public, we can use soup salad variants in eat at restaurant. Enums aren't very useful unless their variants are public. It would be annoying to have to annotate all enum variants with pub in every case, so the default for enum variants is to be public. Struct are often useful without their fields being public, so struct fields follow the general rule of everything being private by default unless annotated with pub. There's one more situation involving pub that we haven't covered, and that is our last module system feature, the use keyword. We will cover use by itself first and then we'll show how to combine pub and use. Having to write out the paths to call function can feel inconvenient and repetitive in listing 7-7. Whether we choose the absolute or relative path to the add to waitlist function, every time we wanted to call add to waitlist, we have to specify front of house and hosting too. Fortunately, there's a way to simplify this process. We can create a shortcut to a path with the use keyword once and then use the shorter one everything else in the scope. In listing 7 dash level, we bring the create front of house hosting module into the scope of eat at restaurant function. So we only have to specify hosting add to waitlist to call the add to waitlist function in eat at restaurant. Okay, adding use and a path in a scope is similar to creating a symbolic link in the file system. By adding use create front of house hosting in the create route, hosting is now a valid name in that scope, just as though the hosting module has had been defined in the create route. Paths brought in scope will with use also check privacy like any other paths. Note that use only creates the shortcut for the particular scope in which the use occurs. Listing 7-12 moves the eat at restaurant function into a new module named customer, which is then a different scope than the use statement, so the function body won't compile. The compiler error shows that the shortcut no longer applies within the customer module. Notice there is also a warning that the use is no longer used in its scope. To fix this problem, move the use within the customer module to or reference the shortcut in the parent module with superhosting within the child customer module. Creating idiomatic use paths in listing 7 level, you might have wondered why we specified use create front of house hosting and then called hosting colon add to waitlist in eat at restaurant rather than specifying the use path all the way out to the add to waitlist function to achieve the same result. Although both listing accomplish the same task, listing 7 level is the idiomatic way to bring a function into scope with use. Bringing the function's parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined while still minimizing repetition of the full path. The code in listing 7-13 is unclear as to where the add to waitlist function is defined. On the other hand, when bringing in struct enums and other items with use, it's idiomatic to specify the full path. Listing 7-14 shows the idiomatic way to bring the standard libraries hashmap struct into the scope of a binary crate. There's no strong reason behind this idiom, it's just convenient. It's just the convention that has emerged, and folks have gotten used to reading and writing Rust code this way. The exception to this idiom is that if we are bringing two items with the same name into scope with use statement, because Rust doesn't allow that. Listing 7-15 shows how to bring two result types into scope that have the same name but different parent model and how to refer to them. As you can see, using the parent module distinguishes the two result type. If instead we specified use standard of fmt result and use standard io result, we would have two result types in the same scope and Rust wouldn't know which one we meant when we used a result. Providing new names with the as keyword, there's another solution to the problem of bringing two types of the same name into the same scope with use. After the path, we can specify as and a new local name or alias for the type. Listing 7-16 shows another way to try the code in listing 7-15 by renaming one of the two result types using as. In the second use case, we choose this new name as io result for the std io result type, which won't conflict with the result from std fmt that we have brought into scope. Listing 7-15 and listing 7-16 are considered idiomatic, so the choice is up to you. Re-exporting names with pub use: when we bring a name into the scope with the use keyword, the name available in the new scope is private. To enable the code, that calls our code to refer to that name as if it had been defined in that code scope. We can combine pub and use this technique is called re-exporting, because we are bringing an item into scope but also making that item available for others to bring into their scope. Listing 7-17 shows the code in listing 7 level with use in the root module change to pub use. So mod pub mod hosting pub use create and pub function eat at restaurant. Before this change, external code would have to call the add to waitlist function by using the path restaurant front of house hosting add to waitlist. Now that this path pub use now that this pub use has re-exported the hosting module from root module, external code can now use the path restaurant hosting add to waitlist instead. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house, but customers visiting a restaurant probably won't think about the part of restaurant in those terms. With pub use, we can write our code with one structure but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. We will look at another example of pub use and how it affects your creates documentation in the exporting a convenient public API with pub use section of chapter 14. Using external packages, in chapter 2 we programmed a guessing game project that use an external package called rand to get random numbers. To use rand in our project, we added this line to cargo.toml file. Adding rand as a dependency in cargo.toml tells cargo to download the rand package and any dependency from crates.io. Make rand available to our project. Then to bring rand definition into the scope of our package, we added a use line starting with the name of the crate rand and listed the items we wanted to bring into scope. I recall that in the generating a random number section in chapter 2 we brought the RNG trade in scope and called the rand thread RNG function. Members of the Rust community have made many packages available at crates.io, and pulling any one of them into your package involves the same step: listing them into your package's cargo.toml file and using use to bring items from their crates into scope. Note that the standard std library is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo.toml to include std, but we do need to refer to it with use to bring items from there into our packages scope. For example, with hashmap we would use this line: there is an absolute path starting with std, the name of the standard library crate, using nested path to clean up large use list. If we are using multiple items defined in the same crate or same module, listing each item on its own line can take up to lot of vertical space in our files. For example, these two use statement we had in guessing game in listing 7-4 bring items from std into scope. Instead, we can use nested path to bring the same items into scope in one line. We do this by specifying the common part of the path followed by two colons and then curly brackets around a list of parts of the path that differ as shown in listing 7-18. In bigger program, bringing many items into scope from the script crate or module using nested path can reduce the number of separate use statement needed by a lot. We can use nested path at any level in a path, which is useful when combining two use statements that share a subpath. For example, listing 7-7 shows that two use statements, one that brings stdio into scope and a one that brings stdio right into scope. The common part of these two paths is stdio, and that's the complete first path. To merge these two paths into one use statement, we can use self in the nested path as shown in listing 7-20. This This line brings stdio and stdio right into scope. The glob operator, if we want to bring all public items defined in a path into scope, so we can specify that path followed by the star glob operator. This use statement brings all public items defined in STT collection into the current scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and where a name used in your program was defined. The glob operator is often used when testing to bring everything under test into the test module. We'll talk about how that in the how to write test section in chapter 11. The glob operator is also sometimes used as part of the prelude pattern. See the standard library documentation for more information on that pattern. So yeah, we will cover this in the next video. Yeah, thank you for watching. Bye.